Hello students, welcome to Siri Part-1. In today's class, let us discuss a new chapter number 6, that is on triangles. In this chapter, we are going to discuss more about similar triangles. Before starting the new chapter, let us recall once the concepts about triangles, whatever the concepts we have learned about triangles, what are the properties, all these things, all these basic things about a triangle. First, what is a triangle? Okay, so name of the chapter itself, triangles, is what is a triangle? What do you mean by that? You know that it is a polygon with how many sides? 3 sides. A three-sided polygon. Or if three non-collinear line segments intersect each other. Okay, three one day line ಅಲ್ಲಿ ಇರಕೂಡದು ಆ ತರ line segments. If they intersect each other, then we get a triangle. Yes. There are types of triangles based on the angles and based on the measures of their sides. Which are they? First, based on the sides, how can we classify the triangles? Based on sides, we can classify the triangles as, first one, equilateral triangle. What is an equilateral triangle? Equi means what? Equal. Okay, equilateral triangles. Here in this triangle, all three sides are equal. If a triangle has all three equal sides, okay, then we call it as equilateral triangle. If only two sides are equal in a triangle, if there are only two equal sides, then what do we call that? It is called as isosceles triangle. Isosceles triangle. And in a triangle, if all three sides are unequal or different measures, then what do we call? It as a scalene triangle. A scalene triangle. So, equilateral triangle, all three sides are equal. Isosceles triangle, only two sides are equal. And scalene triangle, all three sides have different measures or ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. Now, based on angles, okay, based on angles in a triangle, how can we classify them? These are the things you have learned in your previous classes, lower class. Based on angles, how can we classify them? If all three angles in a triangle, okay, are acute angles. Okay, acute angles means the angles measure less than 90 degrees. Okay, then what do we call that type of triangle? Acute angled triangle. Acute angled triangle. Okay, acute angled triangle. If one of the angle is a right angle, it is not possible to have two right angles in a triangle, isn't it? Two right triangles ಬಂದ್ಬಿಟ್ರೆ we can't get a triangle shape ಬರಮಾಡಕ್ಕಾಗಲ್ಲ. So it is, if one of the angle is right angle, we call that triangle as right angled triangle. Right angled triangle. If okay, right angle triangle. Now, if one of the angle is obtuse, what is the meaning of obtuse? More than 90 degree, less than 180 degree. If one of the angle is obtuse, then we call it as obtuse angle triangle. Can we have two obtuse angles in a triangle? Oh, it's not possible. Okay, here also we cannot. Three lines, then line segment cannot meet if we have two obtuse angles in a triangle. So, obtuse angle triangle. Okay, so these are three types of triangles based on angles. And if all three angles are equal, I mean in equilateral triangle, all three angles are also equal. How much they? 60 degree each. Okay, then what do we call? We call that as equiangular triangle. So all equilateral triangles are equiangular also. And we have also learned property of the two properties of triangles. What are they? First one, angle sum property. What is angle sum property of a triangle? The sum of the angles of a triangle, sum of all the angles of a triangle is always equal to how much? 180 degree. So, we call this property as angle sum property of a triangle. Second property, it is exterior angle property of a triangle. What is that exterior angle property? Suppose we have a triangle like this. ABC is a triangle, and here suppose this angle BC is extended till D. Here an angle is formed, isn't it? One angle is formed. So ACD. If I name this angle AB, A, B, C and this as D. Okay, or we can, this is nothing but what? Exterior angle C. This is interior angle C. This is exterior angle C. Now, exterior angle, how can we write? Okay, this is also exterior angle. Exterior angle C, how can we get the answer? This is sum of its opposite interior angles. So, here this see, interior angle and exterior angle together, they make a linear pair, isn't it? Sum up to 180 degree. So, ಉಳಿದಿರೋ angles ಯಾವುದಿಲ್ಲಿ A and B. Okay, so here this one exterior angle C is equal to how much actually? Angle A plus angle B. These are opposite. In case angle is formed like this. Okay, suppose this is the angle. So this is exterior angle A. Okay, if I name this as B, okay, B here only. This is exterior angle. Yeah, this is this one. So this angle is equal to how much? Which are two opposite interior angles, B and C. So exterior angle B, how much it is? B plus C. Okay, measures of B plus C. Suppose we get this part is either here or here. This is extended like this. Okay, then this angle is equal to how much? Opposite. Which are opposite? Interior opposite A and C. This is equal to exterior angle A is equal to what? Angle A plus angle C. This is called exterior angle property of a triangle. Okay, so these are basic things about triangles. Now, one more important concept you have learnt in 9th standard about triangle. What is that? Congruency of triangles. What do you mean by congruency of triangles? Let us discuss generally about congruent figures. What are congruent figures? Congruent figures have same shape and same size. Suppose you collect stamps. Okay, stamps published in a year. All stamps of same size. If you collect, they are nothing but what? Examples for congruent figures. Or if you have 5 rupees coins published in the same year, let's say suppose 1990 ಅಥವಾ ಈಗ 2000 ಪಬ್ಲಿಷ್ ಮಾಡಿರೋ ನಿಮಗೆ 5 rupees ಕಾಯಿನ್ ಅಥವಾ 10 rupees ಕಾಯಿನ್ಸ್ ತಗೊಂಡ್ರೆ, ಸೊ ಸೇಮ್ ಇಯರ್ ನಲ್ಲಿ ಒಂದೇ ವರ್ಷದಲ್ಲಿ ಪಬ್ಲಿಷ್ ಮಾಡಿರೋ ಕಾಯಿನ್ಸ್ ತಗೊಂಡ್ರೆ, if you pile up them one on another, ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಇಟ್ಕೊಂತ ಹೋದ್ರೆ, okay, we get a similar figure, isn't it? Each one, not similar, congruent figure. Each of the coin, okay, they overlap one on another. ಒಂದ್ರ ಮೇಲೆ ಒಂದು ನೀಟಾಗಿ ಪೈಲ್ ಮಾಡೋಕ್ಕಾಗತ್ತೆ ನಮಗೆ, isn't it? So, though such figures are called congruent figures. Squares of same dimensions, that suppose 4 cm, 4 cm square. Another square measuring same 4 cm, 4 cm, 4 cm length, 4 cm. Of course, you know, in square all 4 sides are equal. Okay, so squares of same size we say. Okay, and then shape is square, size is also same. Then what do we call? Congruent squares. Or circles of same radius. Okay, for example, at coins I said, no, circles of same radius. Okay, same radii. Then there are also examples for congruent figures. So congruent figures have same shape as well as same size. So in triangles, how can you define it? Congruent triangles. Congruent triangles. Okay, in congruent triangles, all the sides as well sides of a triangle, all the sides and all the angles of a triangle are equal with the corresponding sides and corresponding angles of another triangle. Suppose we have a triangle ABC and PQR. PQ are two triangles. When do we say these two triangles are congruent? If angle A is equal to angle P. Corresponding angles means what? When you pile up them, ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಇಟ್ಟರೆ the overlapping parts. ನಾ ಈಗ PQR ಅಂತ ತೆಗೆದು ABC ಮೇಲೆ ಇಟ್ಟರೆ ಈಗ P ಮತ್ತೆ Q ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ. R and C ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ. Q and B ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ. So these are called corresponding angles. Similarly, ಈಗ ಯಾವ ಸೈಡ್ಸ್ ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ? AB and PQ ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ. Here AC and PR ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರುತ್ತೆ. BC and QR they overlap on each other. Coinciding we call. Okay, coinciding or overlapping on one another. Okay, these parts are called corresponding parts of the triangles. Okay, so two congruent triangles are said to be congruent if the corresponding parts are equal. That means corresponding sides as well as corresponding angles are equal. Okay, so when can we say these two triangles are congruent? AB must be equal to what? PQ. AC is equal to how much? Which one? PR. Similarly, BC is equal to QR. This must be equal. And another condition, which are the corresponding angles? Angle A is equal to angle P. Angle B is equal to angle Q. And angle C is equal to angle R. Okay, so if these kind of conditions satisfied, we can say these two triangles are congruent to each other. Okay, so this is about congruent triangles. So these are the basic things you have learned about triangles in your lower classes. Okay, now let us come to similar figures. This is the new topic you are learning in this class. You will be learning. Okay, in the 10th standard only, this is one of the important chapter. Okay, definitely you will get one theorem for 4 or 5 marks. Okay, 4 important theorems ide idralli. Adralli 3 more, 3 are very important. Okay, three theorems alli definitely you will get one theorem. Okay, especially SSLC board paper, definitely you will get one of the theorem for 4 or 5 marks. ಹಂಗಂತ ಎಷ್ಟು ಥಿಯರಮ್ಸ್ ಕಷ್ಟ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಕೊಬೇಕಾ ಅನ್ನೋದೇನು ಬೇಕಾಗಿಲ್ಲ. ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಥಿಯರಮ್ ಇಟ್ಸ್ ವೆರಿ ವೆರಿ ಈಸಿ, ವೆರಿ ಸಿಂಪಲ್. ಫಸ್ಟ್ ಥಿಂಗ್ ಯು ಮಸ್ಟ್ ಹ್ಯಾವ್ ಪ್ರಾಕ್ಟೀಸ್, ಗುಡ್ ಪ್ರಾಕ್ಟೀಸ್ ವಿತ್ ದಟ್. ದಟ್ಸ್ ಇಟ್. ಓಕೆ, ಡೋಂಟ್ ಬೈ ಹಾರ್ಟ್ ಎನಿಥಿಂಗ್, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ and practice. That's what we are going to teach in this class. Okay, now let us come to similar figures. Okay, first let us learn the meaning of similar figures. What are similar figures? Before going to similar triangles, let us learn what are similar figures or similar shape or similar geometrical figures. Suppose ನೀವೀಗ ಫೋಟೋ ತೆಗ್ಸೋಕಂತ ಸ್ಟುಡಿಯೋಗೆ ಹೋದ್ರೆ ಏನು ಮಾಡ್ತೀರಾ? ಓಕೆ, okay, sorry for the disturbance. Let us continue now. We were discussing about similar figures. Okay, similar geometrical shape. What are they? Okay, now suppose if you go to a studio to take a photograph, ಈಗ ಸ್ಟುಡಿಯೋಗೆ ಹೋಗಿ ಫೋಟೋ ತೆಗೆಸ್ಕೊಂತೀರಾ. ತೆಗೆಸ್ಕೊಂಡಾಗ ಫೋಟೋಗ್ರಾಫರ್ ವಿಲ್ ಆಸ್ಕ್ ಯು ಯಾವ ಸೈಜ್ ಫೋಟೋ ಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ. ದೆನ್ ವಾಟ್ ಯು ಸೇ? some on 5 stamp size photo, 5 passport size photo, and 5 or 2 large photos, isn't it? Athwa ning frame haaki idbeku ansidre, yes, a big large photo above that, enlarged photo. Okay, so but photographer will he take different photos for this? ಈಗ passport ಗೆ ಒಂದು ಫೋಟೋ ಅಥವಾ ಈಗ ಸ್ಟಾಂಪ್ ಸೈಜ್ ಗೆ ಒಂದು ಫೋಟೋ ಅಥವಾ ಎನ್ಲಾರ್ಜ್ ಮಾಡೋಕೆ ಒಂದು ಫೋಟೋ ಅಂತ ತೆಗಿತಾನ? ಖಂಡಿತ ಇಲ್ಲ. So what does he do? Okay, he takes a single photo. Okay, then let's get the different size photos from the same film, isn't it? ಒಂದೇ film ಅಲ್ಲಿ ಫೋಟೋ ತೆಕ್ಕೊಂಡು ಬೇರೆ ಬೇರೆ ಸೈಜ್ ಗೆ ಮಾಡ್ಕೊಡ್ತಾನೆ. So how is that possible? With the help of the knowledge of similar figures. So here photos obtained are similar. ನೀವೇ ಇರ್ತೀರಾ ಫೋಟೋದಲ್ಲಿ, but size is different, isn't it? Am I right? So this is a good example for similar figures. Okay, so photos you obtained by the photographer in different sizes are nothing but what? Examples for similar figures. Similarly, ಈಗ ಪಾತ್ರೆ ಅಂಗಡಿಗೆ ಹೋಗ್ತೀರಾ, you want to get bowls of different size, same bowls, okay, same type bowls, ಒಂದೇ ತರ bowls ನಿಮಗೆ different size ಅಲ್ಲಿ ಬೇಕಪ್ಪ, ಒಂದು ಚಿಕ್ಕದು ಬೇಕು, ಒಂದು ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಬೇಕು, ಅಥವಾ ಇನ್ನೂ ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಬೇಕು. Yes, so then what do? You get a collection of such bowls, isn't it? ಅಥವಾ sometimes set ಸಿಕ್ಬಿಡುತ್ತೆ, 5 set of 5 pieces, okay, ಒಂದೇ ತರದ್ದು 5 pieces ಬೇರೆ ಬೇರೆ size ಅಲ್ಲಿ. So how do they make such bowls? Okay, by using the knowledge of similar figures. These are examples for similar figures. Understood? Okay. Similarly, can you give some other example? You might have observed same buildings of same shape but of different size. Yes, these are also examples for similar figures. Or toys. Okay, same toys of different ಚಿಕ್ಕ ಪುಟ್ಟ ಗೊಂಬೆ ಒಂದು, ಸ್ವಲ್ಪ ದೊಡ್ಡದೊಂದು, ಆಮೇಲೆ ಇನ್ನೂ ದೊಡ್ಡ ಸೈಜ್ ಇಂದು. ಓಕೆ, ಸೊ ದೇ ಆಲ್ಸೋ ಮೇಡ್ ಬೈ ದಿಸ್ ನಾಲೆಜ್ ಆಫ್ ಸಿಮಿಲರ್ ಫಿಗರ್ಸ್ ಓನ್ಲಿ. ಅದೇ ತರ ಈಗ ಟೇಬಲ್ಸ್ ತಗೊಂಡ್ರೆ ಒಂದೇ ತರದ್ದು ಬೇರೆ ಬೇರೆ ಸೈಜ್ ಟೇಬಲ್ಸ್, ಫರ್ನಿಚರ್ಸ್. These are all examples for similar figures. Okay, so what do you mean by similar figure? Similar figures are nothing but what? The figures having same shape but of different size. Okay, shape ಒಂದೇ ತರ ಇರುತ್ತೆ, ಬಟ್ ಸೈಜ್ ಮಾತ್ರ ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ಓಕೆ, ಈಗ ಬಟ್ಟೆ ಅಂಗಡಿಗೆ ಹೋದ್ರೆ ಸೈಜ್ ಡ್ರೆಸ್ಸಸ್ ಸಿಗುತ್ತೆ ಸ್ಮಾಲ್ ಸೈಜ್ ಅಲ್ಲಿ. ಓಕೆ, ದೆನ್ ಲಾರ್ಜ್, ಎಕ್ಸ್ಟ್ರಾ ಲಾರ್ಜ್, ದೆನ್ ಡಬಲ್ XL. Okay, XXL, double XL. Similarly, suppose you want triple XL dress. Okay, you will get in different size but same shape, same type of dress, isn't it? That is nothing but what? Similar examples for similar figures. Similar dress with different size. So what are similar figures? Okay, similar figures are the geometrical shapes or geometrical figures, okay, with same shape but of different size. I hope now the concept is very clear. Okay, now now tell me now, which are the examples in geometry with geometrical shapes can be given as examples for similar figures? If you take the example of these triangles, can we say all triangles are similar figures? No, it is not possible, because suppose if this is one kind of triangle, I may have a triangle of this shape also. Okay, this is also a triangle but shape is different. Okay, I can have a right angle triangle like this. This is also a triangle but shape is different. Okay, shape and size both are different. Okay, so all these, can we take all like triangles are similar figures? No, it is not possible. So when can we get similar triangles? In which case? When we have equilateral triangles. Yes, what do you mean by an equilateral triangle? All sides are equal as well as all angles are equal. Okay, so here suppose if it is 6 cm, 6 cm, 6 cm, it's an equilateral triangle. Then angles also 60 degree, 60 degree, 60 degree. Whatever would be the measures of the sides. Okay, when we get an equilateral triangle, angles are 60 degree each. Okay, so suppose we can have a small equilateral triangle and one more big equilateral triangle. Next, some more big. Okay, and one more of very big size equilateral triangle. But all equilateral triangles are of same shape, isn't it? Shape ಒಂದೇ ತರ ಇರುತ್ತೆ. Equilateral triangle ಒಂದು ಸೊಟ್ಟಿಗೆ ಹಿಂಗೆ ಈ ತರ obtuse angle triangle ತರ ಕಾಣಿಸಲ್ಲ, ಅಥವಾ right angle triangle ತರ ಕಾಣಿಸಲ್ಲ. All equilateral triangles are of same size, same shape, but size varies. ಓಕೆ, ನಮ್ಗೆ ಯಾವ ಸೈಜಲ್ಲಿ ಬೇಕೋ ಆ ಸೈಜಲ್ಲಿ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕಾಗತ್ತೆ. ಸಪೋಸ್ ವಿ ಹ್ಯಾವ್ ಅನ್ ಈಕ್ವಿಲ್ಯಾಟರಲ್ ಟ್ರಯಾಂಗಲ್ 3 cm, 3 cm, 3 cm. I will have small equilateral triangle 3 cm, 3 cm, 3 cm. Now this is 6 cm, 6 cm, 6 cm. I have both two equilateral triangles but are of different size. Okay, so all equilateral triangles are examples for similar figures. Then which are the other figures? Which is the next polygon? It is a quadrilateral. Quadrilateral means what? Four-sided polygon. Among quadrilaterals, can we say all quadrilaterals are similar figures? No, it is not possible. Okay, so only the squares. Okay, squares can be the examples for similar triangles. Okay, because all squares have same shape. ಈಗ ಚಿಕ್ಕ ಚಿಕ್ಕ ರೂಬಿಕ್ಸ್ ಕ್ಯೂಬ್ ಸಿಗುತ್ತೆ, ಒಂದು ಬಿಗ್ ರೂಬಿಕ್ಸ್ ಕ್ಯೂಬ್ ತಗೊಂಡ್ರೆ ಅದನ್ನ ಹೆಂಗ್ ಮಾಡಿರ್ತಾರೆ, ಬೈ ಜಾಯಿನಿಂಗ್ ಸ್ಮಾಲ್ ರೂಬಿಕ್ ಕ್ಯೂಬ್ಸ್ ಇನ್ಸೈಡ್ ಇಟ್, ಇಸ್ಂಟ್ ಇಟ್? ಕಲೆಕ್ಷನ್ ಆಫ್ ರೂಬಿಕ್ಸ್ ಕ್ಯೂಬ್ ಬೇರೆ ಬೇರೆ 4 ಕಲರ್ ಅಲ್ಲಿ ಅದನ್ನ ನಿಮಗೆ ಸ್ಮಾಲ್ ರೂಬಿಕ್ಸ್ ಕ್ಯೂಬ್ ಜಾಯಿಂಟ್ ಮಾಡಿ ವಿಲ್ ಗೆಟ್ ಅ ಬಿಗ್ ರೂಬಿಕ್ಸ್ ಕ್ಯೂಬ್. Then but small Rubik's cube as well as the bigger one what we used to play. Okay, both are similar figures because both are cubes only. One is small cube, the other one is big cube. Shape is same but size is different. It's a very good example for similar figures. Okay, similarly we can have circles. Okay, circles of different size. All circles are of same shape. Circle is one sort of triangle tara iralla alva. Circle cannot be a quadrilateral. Circle is always circle only. But we can have different sizes circle based on the radius of the circle, isn't it? So all circles are examples for similar figures. But if we have two circles of same radii, then they are called congruent figures, isn't it? Suppose if you have two squares of same dimensions, then they become congruent squares. If you have two equilateral triangles of same size, then they are examples for congruent triangles. Then what do you say by this now? All congruent figures are similar figures, but all similar figures need not be congruent. Yes, because in congruent figures, size, angles and size both are equal. Size and shape both are equal. Okay, but in case of similar figures, size is different, shapes are equal, shapes are same based on the angles and the proportionality of the sides. Okay, so how can we define similar figure? Similar figures are the figures of same shape but are of different size. Okay, now let us come to the point of this chapter, that is similar triangles. What are similar triangles? Let us come to that point now. Okay, so standard examples already I have given that example of equilateral triangle. Now let me explain the same. Now yes, as I explained in the beginning itself, yes, here in equilateral triangle all angles are equal. So what do you come to know? To explain similar triangles we must have equal angles. Okay, only if they have equal angles, okay, then we call them similar figures. Okay, then so here also this is an equilateral triangle. So each of the angle measures 60 degree each and all three sides are equal. So one of the point to remember, okay, similar triangles is what? Similar triangle, all angles must be equal. Let me explain with one more example, that is of right angle triangle I take now. Suppose we have a right angle triangle. Okay, right angle triangle of so let me take PQR, a right angle triangle. Okay, here angle Q is right angle, that is 90 degree, and suppose this is 35 degree. Okay, then how much this would be? How much this would be? 35 degree plus how much is the 90, because one of the 90 degree we have already. 90 plus 90, 180. So 90 minus 35, how much we get? 45 degree. Is it 45 degree or yes, 55 degree. So here angle Q 90 degree, angle R it is 55 degree, angle P that is 35 degree. Okay, and let us assume now, I'll just assume this measures 5 centimeter and this one, let me take this as 8 centimeter, and this I'll take the longest side, it is 10 centimeter. 10 centimeter. Okay. So now let me have one more triangle, one more right angle triangle. Little bigger than that. Let me take this as E, F, G is a right angle triangle. In this triangle, yes, this is 90 degree, and here this is 35 degree and 55 degree. This one. I'll take the, let us assume the sides are here 16 centimeter, 20 centimeter, and this is 10 centimeter. Now can you, I tell both the triangles are similar triangles. Can you find any special property in that? How can you say these two are similar triangles? Can you find any difference or any relationship between this triangle PQR and EFG? Here also, let me take this as MNO, and this is ABC. We have a set of triangles. Okay, in A, this is list 1 and this is list 2. Okay, here I have two equilateral triangles, here I have two right angle triangles. Okay, can you find any relationship between these sets of triangles? Yes. So, what is the relation? All angles in ABC and in MNO, okay, both are equilateral triangles. So, here also, yes, they are angular also. So, 60 degree each. So, what do you say? All angles are equal. Okay. Here, angle A is equal to angle M. Angle B is equal to angle N, and angle C is equal to angle O. Okay, these corresponding angles are equal. Now let us see the sides of this triangle. See this one now, it is 6 centimeter. 6 centimeters each. Okay, and this one it is 3 centimeter each. Okay, so let us, can you find any relation here? That is 6 by 3, how much we get? It is 2 by 1, or 2:1, isn't it? There is a ratio. Ratios are equal. 2 3s are 6, 1 3s are 3. Or if you simplify this, 3 1s are 3 2s are. Okay, when you simplify, you will get 2 by 1. 6 by 3 is also equal to what? 2 by 1. So, 6:3 is equal to what? 2:1. They are in proportion. Isn't it? Both the ratios are in proportion. See now, second set of four triangles. In this, see the angles, corresponding angles. Angle P is corresponding to angle E. Okay, both are 35 degree each. Angle Q is corresponding angle with angle F. Both are equal to how much? 90 degree. Here 55 degree, 55 degree. Corresponding angles are equal. So now see the sides of these triangles. So PQ, which is corresponding side, this is EF. If you want to place them one on another, how do you place now? These sides overlap each other. Okay, so PQ is corresponding to which side? EF. Similarly, then that is, what is the ratio? 8 centimeter for PQ. Okay, then what is the side EF measures? It is 16. So 8 by 16 is the ratio. Now let us take this one. Which one? To PR. PR is equal to what? It is 10. PR 10. Which is the corresponding side? EG. EG how much? 20. 20. Now see other pair, that is QR. QR how much? 5 centimeter. Then F corresponding side to QR is FG. That is how much? 10 centimeter. Now simplify all these ratios. We got three ratios of three sides, isn't it? So 8 ones are 8 twos are 10 ones are 10 twos are 5 ones are 5 twos are. So finally what have we got? All. Okay, so ratios of the corresponding sides are equal. Okay, so what do you say now? These two are triangles PQR and triangle CFG. Triangle PQR and triangle EFG both are similar triangles. Here ABC, each time what do you get here? Ratio 2:1 only, 2 by 1, 6 by 3. Here also 6 by 3. Okay, 6 by 3. Okay, we get equal ratio, that is 2:1. Okay, so what do you say? These two triangles are similar triangles. ABC, triangle ABC is similar to triangle MNO. What is the symbol? Okay, symbol to denote similar triangles. That is angle ABC is similar to what angle MNO. Okay, this is the symbol. Here triangle PQR, that is triangle PQR is similar to triangle which one? EFG. So how do you define similar triangles? Two triangles are said to be similar if their corresponding angles are equal, and second point is corresponding ratio of the corresponding sides is also equal. Okay, two triangles are said to be similar if the corresponding angles are equal and the ratios of the corresponding sides are equal, or we can say the sides are in proportion. Okay, ratios are equal. Equality of ratio is called proportionality. Okay, proportion. Okay, so two ratios are equal. Therefore, what do you say? Sides are in proportion. So, this is definition of similar triangles. Okay, so I hope all of you understood the difference between congruency and similarity. So, this is today's class. Let us end today's session. Join the class and enjoy mathematics in Siri Pathshala. Okay, thanks for joining. Bye bye.